Hello students, now we will be solving memory-based questions of GATE 19. For more video solution on GATE 19, subscribe to our channel and don't forget to click bell icon for instant notification.
Hello student, this is Samir, and in this video we will be solving question from control system, and this question belongs to Bode plot. So the question is, as for an LTI system, Bode plot is given the number of system poles and zeros and P and NZ in the frequency range 1 Hz to 10 to the power 7 Hz is. So it is already given. Now we'll have to see the number of poles and number of zeros. So we can see here this 10 is a corner frequency, this 10 square is also a corner frequency. In this way, all 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6 and 10 to the power 7 all are corner frequencies. So at corner frequency, we will get poles and zeros depending on the slope of the system. So for 10, at 10 frequency 10 Hz, the slope of the system is minus 20 dB per decade. So the slope of the system is minus 20 dB per decade. So we all know that all poles will contribute negative slope and all zeros will contribute positive slope. So for this 10, we will have one pole. Now at corner frequency 10, we will have one pole because this is minus slope. Now at corner frequency 10 to the power 2, what we are seeing is slope is changing by minus 40 dB per decade. So there must be two poles because the slope contribution for one pole is minus 20 dB per decade. Now for two poles, this is minus 40 dB per decade. So here we have two poles. Now at 10 to the power 3, this slope is changed by plus 20 dB per decade. Why? Because here we are seeing minus 60 dB per decade to minus 40 dB per decade. So we are overall adding plus 20 dB per decade. So this plus slope is due to zero of the system. Now at 10 to the power 3, we have 1 0. Now at 10 to the power 4, this minus 40 dB per decade is going to be 0 dB per decade because we are adding plus 40 dB per decade. So this plus 40 dB per decade at 10 to the power 3, 10 to the power 4 is nothing but the slope contribution due to zeros, 2 0. At 10 to the power 5, the slope is again changed by minus 40 dB per decade. So from 0 to minus 40 dB per decade, we are overall adding minus 40 dB per decade. So at 10 to the power 5, we have two poles. Now at 10 to the power 6, the slope is changed by minus 20 dB per decade because this is minus 60 dB per decade. So overall we are adding minus 20 dB per decade at 10 to the power 6. So we have one pole here. So in the range 10 to 10 to the power 7 Hz, we have 1 plus 2 3 plus 2 5 plus 1 6. 6 poles and 2 plus 1 3 zeros. So the options are given, so we can directly see option C is right. 6 poles and 3 zeros of the system. Hope you like the video and don't forget to share with your friends. Thank you.